Yes, now it's recording. Okay. Welcome to the second day, and we will start with a 1 hour session dedicated to the space data model discussion. And so we will start, if I remember well, let me check with the agenda, with Todd King presenting the new features of the new version of Space, version 2.3.2. So Todd, you have 10 minutes.
Okay. You see the first slide, we're up, okay?
Yes.
All right.
Good.
Version 2.3.2 just got released last week, and I'm going to go through the highlights and some of the new features, plus a little bit of an overview, a little history on it. SPACE is a community-developed information model for describing scientific data, in particular heliophysics and space physics data. So it's sort of tailored to fit the needs of that community. Sort of the background of it, back in 1998, there was sort of a recognition in the community that an information model was needed. And in 2002, the SPACE group was formed as an actual collection of people from the community. And in 2005, version 1.0 was released. That was followed in 2009. There were revisions to 1.0 over the time period between 2005 and 2009. 2009 2.0 was released, which has been the base of what the community's been using since then, since we're now at 2.3.2. Now in 2011, SPACE also introduced simulation extensions, which I'm not going to talk much about today, but those simulation extensions were developed by the IMPEX project, and they had used the SPACE dictionary to create a very complete and well-developed model for describing simulations and simulation runs, and that was adopted by SPACE in 2014. So as I mentioned at the beginning, 2.3.2 was released just last week. And so for those that aren't too familiar with the information model, I thought I'd give just sort of the top level view of what is included in the information model. The root document, when expressed in XML, for example, is a SPACE document. And within that document, you have a version, which indicates the version, the model of the version that you're using, because over time, things do change. That's very useful for doing automated validation of the content. And then you have one of a variety of different resources that you can describe. We cover data resources, which is catalogs, display data, which is collections of images, numerical data. We have documents and granules, which are granules aren't really used much anymore. Originally, they were just for the pieces, describing individual pieces of a collection. Then we have resources where data originate from, which are instruments and observatories. Observatory is a very broad category. You know, it includes spacecraft, ground-based, observatories or locations, and also people who provide not only metadata but the data themselves. So they all we categorize as the origin resources. And then infrastructure resources, you can actually describe parts of your system that you use to deliver the data. And then there's an annotation resource, which allows you to place notes, attach notes to anything else. And this has been used, not very often, but to, for example, identify events which are in the numerical data. Now, the new features that are in 2.3.2, really, I'm going to focus on what was added since 2.3.0 was released. But we've added support for DOI integration and generation. We have the ability to capture the information. Well, if a DOI has been issued for the data, we can capture that DOI in the SPACE metadata now. We also have publication information, which augments the SPACE information to capture like the author list and publisher and information like that, which prior to 2.3.1, I think it was, we didn't have that information in the information model. Anyway, with publication information, we can automate the generation of DOIs or minting of DOIs for data resources. We improved the classification system for access URLs. Access URLs are pointers to how you get the data that's being described by that resource description. And those URLs were simply just had a name and a URL. We added a style to the URL, which can be identify the type of interface that the URL points to. One example is happy, which will probably be discussed later in this meeting. But by tagging that, you can have interfaces that read that resource description, the metadata, and provide more clear access to the data. Because of the additional work being done on data and bringing in other types of data into our data portals, we expanded the range of particle and wave data types so that some of this data that hadn't been brought in before could be fully described. And then one thing that in our community, there's a concept now of instrument groups or platforms that might fly on a spacecraft, and the platform can be composed of more than one instrument, and they work in concert together in some way. So we've added support for instrument groups so that you can actually describe the origin sources completely by saying these instruments are grouped together in some way. And then we've added additional types for roles, which are mostly used in contacts, and that's the role of the individual or organization. And we've added some roles that, excuse me, that just help more accurately categorize the role or what an individual does within the production of the resource. Now, SPACE, and in part through people that are part of the SPACE group, have provided a variety of tools and services. One of those are the metadata repositories. We talk about this in different ways, but for most of what's in the heliophysics data environment, we have repositories that are on GitHub and the URLs there. For each naming authority in SPACE, there's a repository, and someone within that authority is managing the content of those resource descriptions. Now, we use GitHub just because it's actually very convenient for publicly sharing all this metadata, and by public sharing, we can just sort of give it, it's presented there for the community, and it's just a way of, having open data, open metadata. There's an online editor that's available. The URL's there, XML editor at thespacegroup.org. What this does is try and make working with, changing, updating the SPACE descriptions, which are typically in XML, and it just makes it easier to work with those if you're not very familiar with just dealing with XML in its raw form. There's also a online validator. So if you have a description, it can validate that everything is correct, or at least self-consistent within the description. And then there are command line tools for working with resource descriptions. And those, a description of that is at the URL given here. And those tools do things like, command line level validation, and that type of thing. So in conclusion, the space information model is pretty widely used. There are 12 different naming authorities currently. We have about 4,620 data resources described. And as you recall, the data resources are sort of collection level. So some of these collections are quite large, and others might be smaller. There's 9,576 origin resources. About half of that are people. The other half are a combination of observatories and instruments. We have 182 infrastructure resources that predominantly is sources of data or data providers. It's another way of looking at it. And then there's 9 tagged resources. There's only 9 annotation type resources. Now, just to recap, SPACE is designed to support everything from observational, experimental, and simulation data. So hopefully you can describe with SPACE the full range of data that's used in research. And I think one of the best parts of SPACE is it's community defined. It's not designed by some ivory tower kind of group of people who think they know what you need. It's defined by a community that defines what they need and puts that in the information model. And also, this is much more prevalent now than when SPACE first started, but everything is open source and open data. And so the sharing of information, sharing of metadata, sharing of data itself is all open. And that's strongly encouraged. That's it.
Thank you, Todd.
Any questions?
I have questions, but maybe other people have questions. So I had I noted them on the on the notepad. So I had a question. I was surprised that the Registry Explorer disappeared from the links. Is this something that is wanted?
Well, this last year we redid the SPACE website, and in that transition, basically the SPACE website now is a generated website. Before it used to be kind of more dynamic, it was running on a Tomcat server and all that. Now it's hosted through GitHub. But that was the one piece that was very difficult to implement in a kind of static setting. It hasn't been forgotten, but because we didn't have it ready, it just sort of dropped off.
But it's definitely in the list.
Okay.
It is.
It's important.
But there's a feature. I'll have to check on this, but I guess it's for the information model, not. Mm-hmm. Yeah. There's that search capability in the information model. I don't know if you've used it, but if you go to the.
I was looking for that the other day and couldn't find it.
Yeah, I couldn't find it either.
We need to take another look at spacegroup.org and figure out even better. We've improved it some, but exactly getting to the things that you really want is still sometimes obscure.
Yeah. Well,
we have to rethink that.
Right. So anyway, there's a pathway to getting something like the Registry Explorer back.
Okay.
It just hasn't been implemented yet.
Okay. I had another question on the use of GitHub, which I experienced for adding resources, and it's I think very nice process and quite straightforward. I still have I've tested it, but it's not implemented, I think, on a general manner. I think there's a way to there would be a way to include continuous integration and validation at the merge step, and that would help the team that is managing each tree, so the naming authority, to make sure that the merge request is validated with respect to the space standard using the validators that are available. So GitHub allows to do that, and this is that would be a very nice technology to add.
Actually, we already implemented something that does the validation on the check-in. On the. I got a feeling that it's actually not activated on all the repositories.
I proposed an implementation on the SMWG. It's not, it has to be tested. That's also the thing. I'm not sure it's working all the way through. So it would be nice to check that, because that helps. That removes. That can reduce the amount of work that we have to do for validating every time.
Yes, and I know it was implemented. Maybe it was just experimental at a time, but I know 6 months or so ago we got some notices from one of the repos that things weren't validating.
Okay,
and I'll go back and revisit that, because I agree with you that having that sort of automated check is very useful.
Yeah, and the last one, then I will pass the mic to John, who had a question.
Sure.
Is there a tool to tag resources, or you have to also submit them through the regular process of GitHub? If you want to submit annotation to a data set, is it something that you have to do as a person managing the data, or can you be an external person submitting an annotation because you want to say something about something?
Right. We never really formalized it, but now with the editor, you could create an annotation resource, and then you can submit it to the metadata managers for inclusion.
Okay.
But it does have to kind of go into the GitHub, which, there's a gatekeeper there, which is whoever's the naming authority.
Does the editor make a pull request?
No, it actually sends the description to the designated manager.
Okay, so it's person, not machine.
Yeah.
Yeah, but for this kind of small, if we want the community to get this up, it has to be very simple. If you have to write an XML file, do a fork of the repository, do a merge and everything, nobody will do that.
No, but you have a good point, because it also doesn't have to be, it could be a simple form.
Yeah.
It doesn't have to be as complex as the editor.
That's what I
mean. Yeah. So,
I think it's important that we have to have some review in the.
Yeah, sure.
Things can't go through all the way automatically. There has to be a human interaction in there, unfortunately.
Yeah.
It's more for, safety and integrity, I would say.
Good point. I'd like to kind of comment on one other thing, is that one of the services it's done is we generate the landing pages, or we generate, a web version, HTML version of the metadata when all this information comes in, right? For all our resources, and those are there for access. They're the ones at HPDE.io. I think Aaron will be speaking more about that when we talk about DOIs, because they're used as the landing page for a DOI. But for the community too, it makes these things very readable and accessible.
Mm.
So,
John, maybe you wanted to ask your question. You put a lot of details in the
Sure,
question
yeah.
already.
It's just a kind of a placeholder question because it's a longer discussion. I mean, the place where happy and space intersect is the access URL.
Mm.
So we've been looking at what recommendations would the happy team have on what goes in that access URL, and we went around in circles a lot because we weren't sure what the intent of the access URL was. Is that supposed to be something to display to people so that they can use it, or is this the machine? Should another person's code be able to pick that up, or should it be both? So that's something to talk about on a future Space Telecon, is the intent of that access URL,
I think I have
because
the
it
answer.
matters.
I think I
Okay.
have the answer for that one, but it's too long to answer right now. But
Yeah.
So this
it's
is
kind of both, really. I mean, if you're reading through the space metadata and you see a
Both makes
tag
it
that says, "Oh,
confusing.
this is happy,"
Yeah,
but you see a tag, this is the happy one.
no, I think we should delay this discussion because we're getting
Yeah.
late anyway. But
we are a bit late.
I have a suggestion now that I think answers all the concerns.
Yeah. But that's true that in this kind of for the access information, and this is a part of the comments I have also, is that if we say happy, if we want to have this metadata machine readable and parsable, it has to be the access point, and it must be somewhere. So we have to have this discussion. That's probably one of the working group discussion that we will have to have. So I propose to go to the next talk, which is the Hugonet, activity. So who is presenting?
Me. Can you hear me?
Yes, we can hear you. Can you share your screen?
Yes.
Yes, good.
Okay, can you see my slide?
Yes.
Yes.
Looks good.
Okay. Video. Yeah. Okay. My name is Yoshimasa Tanaka. I'm working for the National Institute of Power Research Japan. I'm very happy to have such an opportunity to introduce our project. And today I would like to talk about the Hugonet activity for the upper atmospheric study. The Hugonet project Hugonet is the abbreviation of Inter-University Upper Atmosphere Global Observation Network. The Hugonet project is an inter-university project which started in 2009 by 5 organizations: Tohoku University, National Institute of Polar Research, Nagoya University, Kyoto University, and Kyushu University. The purpose of this project is to develop the tools for sharing the upper atmospheric data, which are being archived separately by many Japanese universities and institutes since IGY. The other purpose is to comprehensively understand the mechanisms of long-term variation in the upper atmosphere, and also facilitate interdisciplinary study regarding STP. So the upper atmosphere, which we focus on, consists of multiple layers such as the stratosphere, mesosphere, and thermosphere. In this region, various phenomena are generated by energy inputs both from upper region, for example, solar radiation and solar wind and energetic particle precipitation, and lower atmosphere. So both vertical coupling and horizontal circulation play an important role in the formation of the Earth's atmosphere. So we need to analyze a lot of kinds of data obtained from multiple layers and also from a wide range of latitude, from Antarctic to Arctic. The Hugonet has 100 data obtained by various kinds of instruments such as telescopes, imagers, radars, and magnetometers distributed globally all over the world. In order to understand the coupling processes in the solar terrestrial system, it is important to comprehensively analyze these various kinds of data. So far, we have collaborated with various projects associated with SDP. For example, SuperDAN, IceCat, ERG, PWIN, and so on. And we have supported publishing their data and also provided useful tools for producing scientific results effectively. So our questions are, how can we produce scientific results effectively? And how can we make new discoveries from such a lot of kind of data? So our answers is to connect seamlessly our research procedures using advanced tools. And we remove barriers among various missions and communities. And we contribute to the education of young researchers and promote international collaboration. So our strategy is to help researchers perform comprehensive data analysis by connecting seamlessly research procedures using the advanced tools. That is metadata database, so-called UGNet Type A, and analysis software, IHDEA, for upper atmosphere data. The UGNet Type A is responsible for number 1 to number 4, and IHDEA for is responsible for number 5 and 6. This is a top page of the UGNet Type A. You can search data by choosing the instruments from a list or by specifying the date and time and free keywords. And you can find interesting SDP events from the quick look plot display. And you can get the metadata and quick look plot of the data. And our UGNet metadata is based on the space metadata model, a space data model. So we can easily exchange the metadata with other missions which are using the space metadata. Also, you can interactively visualize data on the web, and the UGNet Type A also shows how to analyze the data by IHDEA. So it guides users to detailed data analysis with IHDEA. We adapted IHDEA as our data analysis software. IHDEA, Space Physics Environment Data Analysis Software, was developed by scientists and programmers of the UC Berkeley and UCLA and other contributors. UGNet has provided the plugin software for IHDEA to handle the UGNet data, and IHDEA includes a plugin software for multiple missions, so it is very useful for the interdisciplinary study about the solar terrestrial physics. This is an example of the researches using the UGNet data and tools. We can easily find and download and visualize multi-mission and multi-regional data, such as the solar wind data and plasma waves in the magnetosphere from RSA satellite, and ionospheric absorption data from the rheometer, and the polar mesosphere echoes from the Panji radar at Showa Station, Antarctica. So, and to diffuse our data and tools, we regularly hold the data analysis workshops in Japan and other countries, in particular in Asia and Africa. For example, China and Indonesia and Malaysia and India and Nigeria. Okay, I skipped these slides, and in future, we are planning to continue our activities such as the support for the SDP research and the promotion of data publication and the education of young researchers. Okay, this is conclusions. The UGNet project has developed the advanced tools for the atmospheric researches, such as the metadata database UGNet Type A and the integrated data analysis software SPIRAS. To achieve scientific results effectively, our strategy is to connect seamlessly the research procedures using our tools. We have contributed to the education for young researchers, both in Japan and other countries, to enhance their international collaborations in the SDP field. As a result, the number of papers whose first authors is a collaborator in the developing country is increasing, and we are planning to continue the support for the SDP researches, the promotion of data publication, and the education of young researchers. That's all. Thank you very much.
Thank you.
That looks very nice. I'm wondering, it looks like it's a lovely thing to generalize as well, so we can get things like Madrigal and SuperMag connected into this whole network of things.
So let me follow up with what Aaron just said, and that is one of the things that IHDEA would like to do is to have international collaboration and coordination and sharing of data. So now that we have, just from this meeting, we know that there are actually people developing their registry, their own network, their own repositories of data. So what IHDEA would like to do is to somehow make the connection between registries and archives so the data can flow more easily, from one system to the other. And then I guess the key thing for that to happen is the open metadata. So the question for you, Tanaka-san, is
yes.
How do we make it happen that we can actually share metadata?
Sorry, once again.
Well, you're saying UGNet is already using space.
Yes.
And there are other parts of the world that's also using space. So it's a more generic question, is that we need a mechanism by which we all can share our metadata holding. Well, so for example, NASA would like to know what metadata you guys are holding so we can search your metadata and vice versa. And you can also search NASA metadata holding.
The GitHub idea of registering everybody in GitHub, each person having their own repository, is one way to do that. I don't know if that's something UGNet has thought about or not.
I think what is missing, if I may, is a registry interface. So we have registry, which are XML trees that we maintain, most of them on GitHub, some others on other places. But I think there is a need for a registry search interface with an API that is defined, and then you can either search or harvest this interface and know what is on the other side. If we don't do that, And then it means that there is also a central place where we should put all these registry interfaces if it's not centralized.
That's right. In fact, I'm going to ask that question later on in the open discussion.
Okay. Good. So and this is a difficulty that I also have seen in space for a long time. It's difficult to. It's okay to now we know where the space trees are maintained. There was the Explorer, but to be able to search directly into space with an API or a search interface is difficult now. So it's difficult to use space.
Certainly across naming authorities at this point.
Yes.
So, quick technical note. The Japanese found it necessary to, or IUGONET, I guess is a better way to say, found it necessary to add some extensions to the space model so that they could classify different aspects of their data. I think we should try to merge what they have added into the base model that we are now using, if that's possible, so that there's really only one version of space that is being used.
That's been successful over the years. I think we should continue to try to do that.
Right.
Okay.
Lee, do you know what that is? You know exactly what the extension is?
I've seen some examples. There were some things that were added that could handle things like geographic extents of ground-based observatories or chains and things like that.
Yes.
And they're able to use those things to do geographic searches. And there's a few other small examples. I'd say maybe less than a half dozen.
Okay.
And it may be simple just to merge it in.
Right. Yeah.
Okay.
Part of 3.0.
3.0.
I think we have to go on. Thank you, Tanaka-san. So we now have two presentations on DOIs. One by for the NASA implementation and one from the ESA implementation. So first, Aaron, if you can share your screen.
Okay, you had I know up first, but I'm happy to go
you want
first.
to skip me.
What?
Yeah, you're going to skip him again.
Sorry, I didn't put it on the online, so that's why. So go ahead, Arno. Sorry. So the online session on the website is not up to date. Sorry.
Don't worry about it.
No, go ahead, Arno. It's your turn.
Okay.
Do you see the right? Do you see the presentation?
Consistent pattern we've got here.
No, not yet.
Okay. Let's see,
That's okay. Small, but okay. Yeah, okay, good.
There you go.
Okay. So DOI is at Science Data Center and its relation to space. So let's move on. So the objectives that we have, we want a direct link from data in papers to our archives, improve findability of our data sets, better tracking of their usage, and improve the reproducibility of published results. So let's kick off by explaining what is a DOI, how this tool can help to fulfill these objectives. Next, why did we assign a DOI to each experiment on our ESA heliophysics spacecraft? What is Google Dataset Search and how a DOI can be indexed by this new search engine? I will then present you how we provide direct link from the DOI to the data in our ESA archives. We'll show you a few examples on the findability of our DOIs on Google. And I will finish off this presentation with the status of DOI implementation in other fields of in astronomy and planetary science and the relation to space, as I said. Okay, quickly, DOI is a persistent URL like this one, doi.org, etc. leading to a DOI HTML page that you can see on the right. There you can see on top the logo of the mission, then the name of the experiment, a URL where you can find the data, the DOI itself, and then all kinds of description of the experiments. In this case, the data sets it generates, the key reference paper, the temporal coverage, the description of the mission, and the PI name. Okay. So as I said, why assigning DOIs, it allows to link publication to the data, improve traceability, and acknowledge the work of PI, and make all these experiments findable on Google, and possibly increase, of course, the data usage. So this is the one slide I showed you yesterday. So this is the link where you can find all the DOIs we have minting for all these missions: Cluster Double Star, ISS Solesis, Proba2, SO, and Ulysses, and Solar Orbiter DOI pages are in the making. So for Google Dataset Search, it's available since October 2018, and when it was released, 10 million datasets could be searched. Now, in August 2020, this is more than 31 million datasets. So it may or may not become the standard for searching datasets, but knowing Google, it's possible. So we decided to get indexed on this service, on this search service, and for that you need to add a JSON script with at least 2 properties, name and description, like here golf and a short description. But of course, you want to add more properties to properly point to your archive, and also properly describe the dataset in Google, and including PI and data publisher. So these are all the properties that we use. I mentioned here that for the PI we use the ORCID ID, and for the institutes the ROR ID, which are unique for each institute. And I will focus on the keywords, and this is especially important to get indexed on Google, but we wanted also to have a relation to space, so I'll get onto that later. So one slide I showed yesterday, if you search, this is the Google Dataset Search URL here, and you have if you search for SO Golf, you see immediately the golf instrument on SO. We put a second line here to specify the mission, because sometimes the name of the experiment is not unique, like a flux gate magnetometer name is used all over the place on multiple missions. There you've got the related articles. This is the link to the key reference article, and then Google is placing this button which links to our archive. It's managing itself this relation to Google Scholar. You've got the data format here, and then the DOI, last updated, and then the author and affiliation, and the description of the dataset. For some experiment, we can link directly to the data itself. So for golf, we have mission long files. So we set up, this URL is pointing to a special page where you can directly download mission long files for these experiments. This is true for golf, and this is true for 4 experiments on SO. And this is not a simple FTP. This is a direct download from our REST API. So people get the latest version of the file each time they click on this. So a little bit of examples here. So not only you can find the name of a SO experiments, for instance, but if you look for time of flight, then because we described it properly, you can find the experiments which are using the time of flight technique. The same on cluster for solid state detector. you get on to the rapid experiment, which is the proper result, the right result. Now, if you look for type of measurements, it's also true. If you can look for ion 3D, and then you will get the CIS experiments and the rapid experiments, which are the two experiments providing this type of measurements. Scientific phenomena, this is where the keywords are absolutely essential. And if you put something like spectral solar irradiance on the ISS, you get as the second result the SOLACIS experiment, which is the right result for ESA, and for NASA you've got the more recent TSIS experiment, which is which operates at the moment on the ISS and basically cover up for or replacing somehow the SOLACIS experiment. Maybe sometimes you don't even need to mention the mission name, like in this case you've got interstellar neutral helium, and then you arrive to the description of the gas experiments of Ulysses. Now this one is interesting because for oral kilometric radiation on cluster, the right experiment is indeed wideband, and Google finds it here because we added oral kilometric radiation among the various keywords that are available on space. So on space, if you go, for instance, for this HPDE landing page, and you look for cluster and then wideband, and you arrive to the description here, and at the bottom of this experiment description, you've got this whole list of keywords, and this is what we have used exactly in the keywords in this JSON script, you know. And for the others, we couldn't find such a detailed list of keywords, so we have interacted with the various PIs on the experiments on these different missions, and we ended up with a list of keywords that we could feed back actually to space, to the different experiments, because those have been agreed by the PI of these experiments. That's a proposal. Now, just a few words about the other fields at the Isaac Science Data Center. So for the planetary mission, there is a nice initiative which is called Guest Storage Facility, and it has at the moment two really high-level data sets with DOI that have been created at the moment of the when the refereed papers were submitted. So now in these refereed papers explaining this digital terrain model on Mars and I think with Cassini as well, I don't remember. And this is really a direct link from the data to the paper. And we want to use this guest storage facility to add really high-level advanced products that are derived from our mission, including heliophysics missions. So for the planetary, they have this facility, but they are in the making of releasing thousands of landing pages and DOIs, one per data set that we store at ESA. On the astronomy side, there are two types of missions: the survey missions, where you have only a few catalogs, so in the end a few DOIs for Planck or Gaia. But for the observatory type missions like XMM or Herschel, this will result in tens of thousands of DOIs and pages, and that we can generate automatically. The only aspect we could really improve here is the automatic keyword extraction from the scientific proposal, and there we will work on using AI techniques to extract these keywords in a clever way, hopefully. So the next steps is really to provide DOI on demand, because basically what we see in papers is short time periods, case studies from a few data sets that are used, and they are very short compared to decades-long files. So we want to provide on-demand DOI that could link papers directly to the data bundle used in the paper via DAP or via our REST API. And such a service is available, for instance, for Hubble data at the Canadian Astronomy Data Center. So this is, of course, technically feasible, and this is something that is important because then you really go exactly to the data that are used in the paper. On top of that, we want to save the version of the data used in papers to improve reproducibility. Like missions like Cluster or SOHO do not preserve the very old versions of the data, and so you cannot really indeed reproduce the figures that were published in 20 years ago or 15 years ago. And there is an important aspect maybe we should discuss at some point is about the data quality, because you see this zoo of millions of data sets that are available, but for newcomers, which one should they use is sometimes very difficult, and we don't have among our ESA missions, but internationally, I don't know about any very data quality standard, and maybe this is something that we could build some kind of working group on maybe. There is some a recent paper that is quite interesting, which are using some kind of star to rank the data. I mean, something like that could be maybe thought about. And I think that's it. We just released about 50 DOIs for our ESA heliophysics experiments that we carry on our spacecraft, and they are searchable on Google Dataset Search. And we should have a paper that should be approved soon, and that will be published in COSPA about this. And that's it for me. Thank you.
I have one question back on slide 13.
No, too fast.
Yeah. Oh.
13. Okay.
There we go. The one you have highlighted, the CIS ion spectrometer.
Mm-hmm.
The next one down, cluster ion spectrometer, actually points to the page generated from the space description,
Yes.
which may actually be for the same resource. And I'm wondering if we need to be concerned about reconciling what's being pointed to.
Yeah, so this is an open question. I don't know what would be the best solution here.
Yeah, because they're probably okay to have both, but I just wonder if somebody that isn't aware that they potentially are pointing to the same resource, they don't have the same title.
I think in the JSON the schema.org metadata, you can say that the resource is the same as another one. I don't know if that can be. I think it's there.
That might be helpful. That's true.
I think we're going to have a lot of that as time goes on, just because things come from different directions and you don't have any control over it. And so it's hopefully people will be able to figure it out. Having two ways to get to something, even if it's sort of the same thing, is better than none.
Yes,
That's true.
Sure. Well, I just wanted to point that out in case we want to consider.
Well, I don't know if they are the same resource, though. The HPDE landing page only points to what's on CEDAWeb.
Yeah, so those are two different data sets.
Okay.
And now if I do the search again, HPDE is the first one.
Yeah, that we cannot control. This is Google.
But it goes directly on the space resource, and the space resource, since it's an instrument, it doesn't have access to data.
Ah, okay. Yeah, okay. The mapping's different. Yes.
Yeah. So that's a big
The
difference. In one
HPDE
case,
one
you
is
get
not going-
data. On the other one, you
Yeah.
don't.
HPDE one wasn't systematically generated. I don't know how it came up. I mean, they've
No, but
done some-
since HPDE is referring to an instrument, on an instrument page on the HPDE, there is no access to the data. The data is on the numerical data record.
Yeah, I was going to ask that question. I was behind you with the search on Google.
Yes, sorry.
It seems like you'd want to be limiting yourself to searching numerical data products, display data products, and catalogs only.
For data
You
set,
can do
yes,
that.
I would say
Yeah.
so. Yes.
Yeah.
This is
I think
data set
that-
search. Yeah.
Nice thing about Google search is it'll search everything, and the bad thing about it is it searches everything.
If you put a schema.org metadata, it will be there.
Right.
It'll be there, but right, it's just that it's indiscriminate in some sense, and so it
Yep.
requires the user to have some knowledge. Not so bad though.
Can't we put in something so it doesn't search down the instrument tree? Google doesn't spider down that. Todd knows the answer, I think.
No, there's a complication because SYS itself does not have its own data. It splits into CODIF and HIA.
Yeah, on top of that, yeah.
You search one more level down to get to the data.
It's an experiment or an instrument suite in the US.
I'll mention that at the end of my talk, how I think.
Yeah, that.
Okay.
Well, just one comment. Because, as pointed out, that's an instrument, not a data set. We probably should not be including the schema.org information in it, because if that schema.org information's in the metadata, Google will index it and put it in this list here.
Yes.
So technically, it's not a data set. So
Correct.
you probably shouldn't be calling it a data set.
Right.
Correct.
It's more a collection to be precise, yes.
Well, it's not even a collection, really, because it doesn't point to any data.
It's an instrument description.
It's an instrument description.
And that's something that's being worked in this community of how you deal with instruments. The only thing in DataCite that you can call it is a physical object, but that's more like a moon rock. That's not a.
Yeah, and schema.org is different than DataCite. Those are two different beasts and two different standards.
Yes.
True.
Yes.
True.
Yeah.
Okay, I propose to go on because we are really late. It's a very interesting discussion, but we have to
I'm
go
going to
on.
make
So-
my.
Can I ask a quick
I'm next,
question?
right?
Sure.
Yeah.
I'm Masahito Nose from Japan. Could you explain again how to make your dataset indexed to the Google dataset search? Maybe I missed your explanation.
Okay.
You said JSON format?
A JSON script, yes.
Script. Okay.
It's not a script.
It's a JSON script in the HTML.
It's a JSON document that is included, the metadata that is included, and that follows the schema.org data model.
I mean,
where are you using for
You
this
embed it in
JSON script?
HTML.
if I may,
You
Baptiste,
embed it in the HTML landing
Go ahead.
page.
if I may, it's actually a script
Okay.
like this, you know.
Yeah, okay.
I don't know if you see my.
No, we don't. It's great.
Okay. Because someone is
It is.
sharing. Okay.
Now it's okay.
Oh, I was starting to share in your HTML. You put something like this.
Okay. So maybe you can make it bigger.
Yeah.
The main thing is to realize that you're embedding a JSON script in the HTML page, right?
Yeah. So
Right.
on the day,
Okay, so
Schema.org, you can get the content.
you put this JSON script in the landing page.
yes,
Yes.
exactly.
So
Yes. Yeah.
Google is crawling this your landing page. Oh, okay,
Right.
understand.
And
So if
Some of
we
this,
make our dataset index to the Google dataset site, we should include this JSON script in the
yes,
landing page.
yeah.
Okay.
And
Okay.
I will send you the article that that we wrote on that, which explains all of this.
Okay. Thank you.
Okay.
Okay, Aaron, let's go.
okay, I'll try to make mine as short as possible. Let's see, I just want to make this full screen. Everybody in?
Yep.
Okay, good. So I was asked to talk about the NASA version of what we just heard. So I don't have to describe what a DOI is and all that. I'll just describe the unique things about our approach. We're doing it from a quite different perspective initially, though I hopefully will be merged in the end, and I have a suggestion for partly how to do that at the end of this. The main thing is we're using the SPACE pages as the landing pages. So they provide the information, and then we embed the DOI information, the creators and the repositories and all that. We embed that into the SPACE, and so the SPACE landing page has everything you need. So that's our main approach. The difference is we're dealing with the data set level, not the experiment level. So it's very much fine scale as opposed to the initial approach from ESAC. So here's the basic idea. What you would do is when you cite, you would cite in a paper the data set just as you would any other paper or other thing. So if I would said Russell 1987 in the context of some discussion in an article I was writing, then in the bibliography for that would be this entry down the third bullet, and the DOI landing page should just come right up. Hello? It's getting there. There it is. Okay, good. And you can see there's the data access on the left here, in different routes. We want to, that was the discussion we were having of how to add
We only see your
data set access.
Yeah, you need to get off
in your PowerPoint.
full screen.
Oh, it's the full screen is, oh, it's not including this. Okay.
It's locked
really
to your
full screen.
PowerPoint.
Okay, so
Escape.
do I have to?
I believe you, Aaron. So if you want to go ahead, that's fine.
Yeah, right. Here it is. Can you see it now? Did it come up?
Not
No.
yet.
No, because
we only see PowerPoint.
Yeah, PowerPoint. You only share PowerPoint.
Okay.
Right.
Okay. Yeah, that's. I know exactly what I did now in retrospect. Okay, so I'll go back to it. Anyway, you click on that, you see the thing, you get the information. One of the things that we've been trying to insist on is that you put when you accessed it, because we're so bad in heliophysics at doing versioning that you can't say version 3 and have a meaning to that usually, except in a very few cases. So if you say when you accessed it, you have at least some hint of which version of stuff you're using. We now can mint these. We are part of DataSite, which is the same thing that many of the other people are using. All we need from the users, the producers of the data, are the title, which comes from the SPACE record, the creator, which is this list we're going to generate to some extent manually, and the publisher is just where the thing is stored, and then the publication year is kind of an arbitrary thing. But you don't need a lot of extra things from once you have the SPACE page, you don't need a lot of extra things to get the DOI and the DOI into the SPACE page. Okay, I think I can probably skip all this. Should be in the online version. Publisher is the source of the data. Typically, if there is a long-term data storage place like Planetary Data System or the Space Physics Data Facility, that should be included in the publisher. But you can also include, if it's also at another place, you can include that as well. It's very flexible. And as I said, this all goes back into the SPACE page. And then we can, when we do when we show the landing page, it shows also a way to do the citation, the bibliographic citation. Let's see. Yeah, this is, again, just repeating that the hpd.io is where the DOI link actually references type of resources, a data set for most things, collection for display data, and that was the discussion that was just going on about what you do with the experiment, which is a little bit sort of a hybrid in the way it's being treated in the European context. Okay, now this is the main thing I wanted to get to, is the DOIs in the IDEA context. Given that ESA is minting DOIs at a general level, like sys on cluster, and NASA is producing individual data sets, there's sort of a mismatch. But one thing that can be used to consolidate these is that there's a relationship that you can use within the DOI. If you look at the schema in you can do things like this DOI is a part of that DOI. So they don't have to be unique and non-overlapping. So for instance, if you did the DOI associated with a particular thing in a paper, a particular piece of a data set, you could say then, you could put in that link, this is part of this larger link. So that's a way to hopefully, to some extent, merge our efforts at this point, is to use this relationship that's included in the DOI specification. That's not in it. That would be part of our SPACE 3.0 effort, I think, is to include this as part of the information that's in the DOI, this relationship. And I also want to note that we've discovered in this meeting that JAXA is also doing DOI minting, and other people are doing DOI minting, and we have to then coordinate with those people how we're working things as well. So I think that's it. Yeah.
Can I add one thing, Aaron? In SPACE, we just have a tag for the DOI. It doesn't require minting by anybody or any group in particular. If you have a DOI, you just put it in.
Right, and in particular, like the data portal, we would just, if it was a NASA DOI, it would include the usual things, but if it was somebody else's DOI, we would put that into the description in the data portal and link to their homepage rather than our homepage.
Right.
Yeah. Then the landing page is that of the DOI minting agency.
Yeah, it's the landing page is whatever you registered when you minted the DOI. Yeah.
So in our data portal, we would have an entry which was just the SPACE entry, and then an entry which says DOI, and the DOI one would link to whatever the native DOI was, not ours.
Now, when we, being NASA or Aaron, mint a DOI, we also cross-reference the SPACE resource ID that's been registered, which you can do with other identifiers too. You can do any identifier that's external to the DOI. You can actually map the two together at the data site or DOI.org registration.
Yep.
And of course, when you put the DOI in a SPACE description, you're doing the reverse on the SPACE side. You're associating that DOI with that particular resource ID and that description. So,
yeah. Then there is another way, but that might do it a little bit. That might not be homogeneous from datasets to the other. What could be done is that the SPACE descriptor, SPACE resource descriptor, the file itself can have a DOI, whatever, even if there is another DOI on the dataset, for instance. But then you can use the relation is metadata for, and you say that this SPACE record is the metadata for that resource. And this is completely acceptable. Then that might be confusing because you would have HPDE.io pages for datasets or for only metadata with link to data. So it's, could be a bit confusing.
Sounds
we have a kind of integrated approach from our point of view, so we haven't thought about that. I mean, I know the Japanese, for example, in some of our discussions, have the IHDEA people making. There's a set of people making DOIs, and they want to have those their SPACE information have a DOI in itself, and that's as you said, it's perfectly fine and it works.
Sounds like we need to set up a working group.
Yeah.
Well, yes, in part. Right. I didn't mention it during the SPACE this presentation, but Aaron just did. Where there is talk about doing a SPACE 3.0. In other words, the next generation of the information model. And things like this, like how do we, the way we modeled the DOI and the publication information was sort of an add-on, and we could go back and revisit that and maybe get a more complete sort of model of how we want to bring these two identifier systems together in some way within the SPACE metadata. And, I think that DOI-A as part of DOI-B is something that's important to capture. Some of these other things that have been mentioned would be important to capture. And so part of that working group, Xing, would be how do we want to reshape SPACE to better align with the way things are being done today in the community?
That's a good idea because we need a DOI working group. There is another possible working group discussion on Thursday about 3.0.
Yeah.
So we could do it then. I think today we need to go through a lot of other presentations. We only have 45 minutes to go.
Yeah. Maybe we can rearrange the schedule, but we will see.
Notice that there's a question in chat from Jean-Christophe.
On the chat. Yes, sorry.
Yeah, I see that. That could be a long answer.
Yeah.
This is different. Yeah. But,
A question for the talk?
The question is, what feature does Google Dataset Search offer compared to the DataSite search? How do they differ?
Well, and in fact, there's yet another search, which is like our data portal search, which is very, very much specific to this set of data sets. So, yeah, they're all different.
Shu Wagan asked a question, is anybody thinking about creating DOI for model output?
The answer is yes.
The answer is absolutely yes. It's already been done. It's already being done. Ray Walker did it with Todd, I think.
Yeah, I was starting to type that in, but since you said it. There's no limit. And it gets easier if you do a SPACE description because we can mint those rather quickly for you.
Okay.
So.
Okay, so let's move to the next talk. So that was Xing for discussion.
Oh,
so
you're not doing the.
Oh yes, sorry.
Yeah.
I'm a bit tired. Sorry. Let's do it. Yeah, I lost my screen. So we can do the short the short showcase. So I will. I have the slides. So I ask you to stay into the few minutes. Share the slides now. Where is it? It's here.
You want to stop sharing, Aaron? There you go.
No, that's fine.
I can't
Just
find how to
bumping.
stop sharing.
Oh,
I did that as
so
That's okay. He bumped you.
So you
fortunately
you
I
see
don't have to
the
stop sharing and it takes over.
okay. So
It's fine now.
yes. So the first is Vincent. Vincent, you go ahead.
Yes, you hear me?
Yes.
Okay, good afternoon. So I have 3 minutes if I understood.
Yeah, something like that.
Something like that.
The shorter, the better.
Good. So I have 2 slides, obviously. The idea here is to make a short recap of what we are using in AMDA. And so we are using space. So a short introduction is that AMDA is distributing space physics data for 15 years now. We have public data from the different repositories. We also have private data, but here I'm talking more of the public ones that are exposed to the whole community. We also have simulations and models. And for all of this, we are using space at all levels of data description. The next presentation will be about simulation, and I won't talk about it now by Ronan. So we have something like 600, 700 data sets, and down to the level of parameter. And what I call a parameter is shown on the left side of this slide. So it's a bit small. No.
Sorry.
Yeah. So this is a figure on the left. So this is an AMDA tree. And so the little icons that you can see are all missions. And when you go down to the directory, you go to the instrument level, dataset, and then parameter. And we have a space description for all levels. And at the parameter level, we have an XML, which is built from the space registry and from some specific blocks that we need for AMDA, which are the get, the process, and the output tags, which describe for our own system where to get the data, how they are processed, how do they use the calibration data, files or whatever, and what are the kind of output that we are expecting typically for this parameter. So on the right side, you see a basic scheme of how we do. We have a space registry. We have also the way we compute the parameter. We give information on the parameter, and from that we are able to build the data tree at the mission, instrument, and dataset level. So on the next slide, what you can see, Baptiste, please, thank you, is just how we use space here at the mission level on the left. So we have a resource name for the observatory. We have an alternate name for tooltip. When you put the mouse on ACE, you see that the full name is Advanced Composition Explorer, this kind of thing. And then we have this. We also have the operating span for each observatory, which are in AMDA, and we have the same thing at the instrument level and also at the dataset level. An important part of the user space is to build the help that we have in AMDA. So in AMDA, on the data tree, you have a little blue eye, and when you click on it, you have information help on the different levels that are used. So here on the right, you see the help for the ACE mission at the mission level. Then And so each block that you see is built from the space descriptor that we have. Okay, so I think I will stop here for this.
Okay, thank you, Vincent. I propose to go fast into the presentation, and we will discuss later if we have questions, okay?
Yeah.
Ronan Modolo for the Tempête project and the simulation runs.
Hi, everyone. I will try to be short.
Yeah.
So if you can hear me.
Yes.
Yeah. So I would like to give you a preview of a project that we are trying to push right now. It's called Tempête, and the goal of this project is to investigate the response of planetary exosphere and magnetosphere to solar extreme events. So CME, CRR, flares, and we have limited our project to different bodies, celestial bodies like Mars, Mercury, and also Earth. So we are widely using a space data model, which has been, as Todd King mentioned earlier, through this workshop. It's an effort which has been led by the INPEX group, and which correspond to our starting point in this project. So we use a unified protocol to share information. So we need to have a dictionary which is able to describe observation and simulation, and Space was doing this, and to develop some standard methods to be able to make some data analysis and make this data analysis from machine to machine exchanges. And we have been defined in this project also some standard formats for exchange, so mainly VO tables and other kind of format like NetCDF. So in this project, in this Tempête project, what we try to do is to evolve a little bit the space data models. And the evolution that we are trying to take into account right now is to include more kind of simulation models. And so right now it was limited to particle in cell, or let's say magnetospheric or plasma physics simulation models. And we in this project we needed to be able to describe neutral upper atmosphere models, so exospheric global models. So we need to update a little bit the new type of inputs, so some neutral quantities and also some new geometries, because so far it was described only in Cartesian coordinate system. So we needed to also to update a new geometry with spherical coordinate, which is the system used by the EGM. And we are also willing to make time-dependent simulations, so to see how, let's say, a variation in the upstream conditions in the solar winds affect the magnetosphere and the neutral environments. So by doing this, we need to have some snapshots on the simulation, and we need to be able to refer to this snapshot in the data model. So we need to describe the input parameters are changing in times, and we need to take into account this kind of information in the data model. So this is what we are trying to do. And also, since our simulation is a coupled simulation, so we are using both, let's say, upper atmosphere model and plasma model of planetary environments, which are linked together. One is using the other as input. So we have some chain models, and we need to describe correctly how the let's say one simulation is used as input resource in the other simulation. So we need to update a little bit also a few parameters and few elements here. So in this effort, we try to update a little bit the data model to include all these kind of quantities. So if we go to the next slide of quantities slide, what we can see is some example of what we want to do. So first we'll have a catalog and a simulation database showing some data products of these exospheric global models, with a possibility to connect to VO tools, to download and to describe all the simulation runs. And also to link this data product to other visualization tools like 3D View, which have been developed by CNES and CDPP, and which give a possibility to have a 3D context of the simulation and of the trajectory of the different spacecraft, as well as to implement or to load some data in the frame, in the scene. So this is what we want to do, to give also the possibility to propose new functionalities in the 3D scenes, like being able to compute the column density in a neutral environment according to a given spacecraft, a given instrument, and a given field of view, but also other kind of functionality such the user could determine, let's say, the altitude where you want to have some data products on a shelf, for instance, and visualize it. And also to be able to visualize time-dependent simulation, so it will be a moving frame simulation. So according to the spacecraft position, we will be able to see the evolution of the response of the simulation of the environment according to input parameters. So yeah, that's it. And there is more information on the full presentation.
Thank you, Ronan. So now I will try to be very short. So here I just kept, I just kept the last two slides of our presentation with the discussion points. So I've been registering observatory, instruments, persons, repositories in the SMWG tree. That works well, as I said, with the Git process. We have added so the ORCID for persons, which is very good. It would be nice to consider to use also the research organization registry and the registry for research data repositories, which are independent identifiers that can be used for organizations and repositories. There's a question, a long-lasting question that we will not answer now, about who will be curating and managing the ground-based observatory, GBO tree. I'd already asked the question about continuous integration and testing, so I'll skip this one. We know it's ongoing. I also started registering numerical data for my resources, and I'm still stuck at some details. And especially since I have extra types of access points which are not listed, like data discovery service on Vespa or DAS2 interface. So there is clarification needed for providers to be able to fill the access information correctly, and probably also on the tool developers on how to interpret the information that is in the access information. And this comes back to the question of John earlier today. About DOIs, there was, so we discussed that, so I don't go into the details. One recommendation that we could propose is that on a landing page that is not at hpde.io, for instance, the ESA one, we could have the recommendation to, from that landing page, to point back with a link to the hpde.io page, so that this information is visible also. On the access rights, also, I noticed that we have only 3 levels: open, partially restricted, and restricted. And now most of the data repositories, maybe outside NASA and ESA, are enforcing the usage of licenses, and mostly is Creative Commons licenses like CC BY. So we need to model those elements and probably add elements in this attribute list. That's it for me. Oh, I'll stop the sharing. So, Shin, you had some slides, I guess. So just to make a short point, we are basically 45 minutes late. So I propose to have the discussion now, and we will start with the showcase of the next session, and we will discuss at the end if what we do. Okay, let's go.
Okay, you want to do this now? Okay. Well, I only have one slide. I basically just try to point out some of the issues that perhaps IDEA as an organization could help. So, in fact, this issue has been brought up several times in the meeting already. So we talked about space and happy inside. By inside, that means is whatever system is already using either space metadata model or the happy interface. And then the need for open metadata. So I've identified a few issues relative to the two items. So in order to support systems with space inside, so whatever systems currently with using space or happy in the system, we need better communication with the current system. That means that if, for example, if we have a new release, as Todd just mentioned, all the people who are out there who are not really connected to NASA need to know about the updates being released. And we also need the feedback from the people who are using it. So in fact, a lot of the space group, even though we have biweekly telecons, we don't hear from the outside users much. So we need to establish a good way for that communication to happen. We also need coordination between different systems. As we now know, for example, the IUGNet and the CDPP, they are using space, and there's very little cross-calibrations between systems and services. So we need better coordination. That's actually talked to the DOI part that Tishu just mentioned as well. Okay. So for better coordination, we really need to have open metadata registries that allows communication between systems. And we need a clear definition of naming authorities. This is one big thing that we're going to have, sure we have a working group for that. To go back to your GPO issue, we really need to have a better definition of the naming authorities. Now, since we have different systems, it's very likely that you have different systems pointing to the same or slightly different resources. So there's a risk of having duplications of descriptions between systems. So now it comes back to, if we had distributed registries, how do they communicate? But if you need to have, like you said, a registry interface, that's another layer of maintenance that each one of us has to do. And effectively, as a user's perspective, they don't care how many registries you have. They just talk to one interface to get to whatever registry. So to the user, effectively, is a single registry, okay? If at the end we want to get a single registry, why don't we just create a single registry to start with? That way, you automatically eliminate the duplication problems. Okay, so that's for the working group to think about. The other problem is, we also need to encourage broader adoption of the standards, both happy, space, or whatever new standards we come up with. For that to happen, we need to have increased community awareness. Even now, if you go to AGU, if you attend any of the science sessions and you talk to them about, hey, we're using space to facilitate your search for data, and they'll come back and ask you, well, what is space? What is happy? So the community itself is not in tune with what we do for them. And I think that's a big problem. Now, in order to make the rest of the community to start adopting our standards, we have to lower the potential barrier for them to use our tools. So we need to create tools to make things easy for them to use. Baptiste, you also mentioned that problem. So we also, the tools need to adapt to all kinds of data sources. Space-based data, space-based, you have satellite, rockets, and balloons. Ground-based data, you have all kinds of telescopes, all sky camera and what have you. And of course, we also have now the model data to contend with. The tools has to be able to adapt to all data types and measurement types. So this is really a major challenge for IDEA to work on. So with that, I open the floor. Or we can have further discussion on Thursday, given the time.
I would say that there is no urgent question. Maybe one. But that's good discussion for Thursday. That's true. And many points were already discussed and question asked earlier today with most of these points. Todd, you wanted to say something?
No, I mean, if we're going to have a discussion on Thursday, it was just a comment really on distributed registries versus single registry. Shane makes a good point in that the data portals are the aggregators from all the registries, presumably. And so behind the scenes, I don't think it's as important to have it a single registry or distributed as long as you can aggregate. And my personal preference is to have it distributed so that naming authorities actually have autonomy over their domain. But that's kind of a philosophical point of view on it.
Mm-hmm.
Well, yeah, that's right. So I think naming authority is an important discussion we need to have, and that's an evolving concept.
Yeah, if I can comment, being in the three planetary heliophysics and astronomy world, in the astronomy registry, for instance, there are many data center registry that are sharing resources, but there is a registry of registries which is centralized and replicated. So fail-safe. And if a tool wants to know what are the resources that are available, he first queries the registry or registry to get the list of the registries he should ask to the question. And so there is a centralized small set of metadata that just that is replicated and that tells the tools where to find the registries.
Okay, so that's a super registry.
Yes, yeah, and this one is lightweight, should be, and goes down and could go down to the name authority ones.
Yeah,
but that's an extra layer. That's not easy. Okay. Good. So let's keep your questions for maybe Thursday and the preparation of the working groups. We will have 1 hour to discuss this at least. Okay. And let's switch, if everybody is okay, to the next session, which will be. Let's see how it goes. Let me open. So I have all the slides from everybody, because this is a showcase only session. So let me share my screen. So everybody should be ready. Where is it? Here. Share. Okay. Good. So first one is by John. So you have 3 minutes.
Very good. Thank you. Can everyone hear me?
Yes.
Okay. So this is just a quick update on HAPI. I'm not going to spend any time talking about what it is, but one of the interesting things about it, let me mention the collaborators. I've got Bob Weigel highlighted there. A lot of the work this year has been him, so I just wanted to highlight him, but it is a team effort with lots of people pitching in. One of the interesting things about HAPI is that it is starting to be used in multiple places. So I collected here a list of all the data servers that are using it right now. C2Web has an implementation where they created it from scratch themselves, and that was Nan Blal who created it. And they're seeing the heaviest usage. There's an SSC Web HAPI server, and it uses the Node.js front end. I'll talk about that a little bit here in a second. At LASP, they have one. University of Iowa, I have one that was kind of a reference implementation. Fundamental Technologies, and AMDA has just stood theirs up. And there's 3 other that are sort of works in progress. CCMC has one for their ISWA, their space weather data products. The PPI node for the PDS has one, and ESAC is working on one too. The Node.js is highlighted. It's starting to be used in a lot of different places. You can get a HAPI server up and running in days using this thing because it handles all the HAPI front end stuff, and you just do scripts on the back end. So look into that if you're go ahead and stand up a server. Next slide, please. We are expecting some changes coming to Happy. There's a list of all the issues you can get to on GitHub using that link at the top. The first one is a cosmetic change, but it is a change in the interface itself where we're just trying to clarify some pieces in the interface. We're going to add a new endpoint as well where you can describe some details about your server. We're going to allow you to specify if you have a units schema so people can possibly interpret your units. The big one, though, is number 83, second from the bottom. Allow time varying bins. Some spectral ranges change with time, and you can now link that spectral stuff instead of just to content in the metadata that's fixed for all time. You can say, hey, this bin range or center comes from a data parameter. So there's other minor changes too with error states, and you can put links in the metadata if you need to. So there's some changes coming. Fortunately, if you saw on the previous slide, everybody who's implemented it so far says, yes, we're willing to keep track with the changes. So we will communicate closely with everybody about that so that you know when this is coming. Okay.
Okay, thank you, John.
I didn't have, yeah, that's it, yeah.
No, it was
lots more to say, but I'll stop. Yeah.
3 minutes sharp.
Okay.
Thank you. So, Chris, hello. This is your time, so I'll let you talk.
So, can you hear me okay?
Yep.
All right. So, I'm Chris Biker from the University of Iowa, and I work a little more closely with instrument hardware than probably a lot of people here. And one of my duties there at the university is the maintenance and improvement of a multi-mission software support system named DOS2. And so it's rather efficient for navigating long time series data sets. And in the online materials, you'll find a software demonstration and an overview of the system. I hope you'll check that out. Now, many people here might use Autoplot, and you may not know, but DOS2 servers and the core display libraries inside Autoplot were initially developed at the same time to work together. Now, that doesn't mean they aren't useful separately, and not every use case involves navigating large data sets. So 2 years ago, I put together a DOS2 Python client library, and this was done to help scientists that are more familiar with NumPy and Matplotlib. But you know, many scientists still use IDL. So this year I created a new set of IDL system routines called DOS2DLM, and it's just like any other IDL extensions. The installation's trivial. You just drop the binaries onto your DLM path and go. And SpeedOS is now in turn using this module to read DOS2 servers, and as of just this month, you can download a version of SpeedOS with DOS2 support. There's also, if you like, a pure IDL client library called DOS2 Pro. SpeedOS couldn't use that due to a version issue. One nice thing about it is it converts all times on the input stream to TT2000 automatically. Next slide, please. So at this point, DOS2 stream definition is about 17 years old. And I'm just bumping up against the limits of the expressive power of the current version. So in preparation for the tracers mission that I'll be working on, I've been working on stream refinements. Now, we're not changing the basic mentality of the streams, but there are improvements. Implicit relationships and definitions are going to be made more explicit. New value types are available. Length limitations have been removed. It's easier to validate. And most importantly, the new definition is extensible, because I don't know what I'm going to need in the future, and I don't know what other people are going to need. So once we roll out these upgrades, we can plug in future needs without disrupting existing clients. And one key point I want to make is that there's no plans to insist on upgrades to current 2.2 systems. You might be able to see in the small text there that the new stream validator supports both the current version and the next version. Heck, we still support 20-year-old DOS1 streams, but I wouldn't recommend anyone using those. And of course, with a stream refresh comes a documentation refresh. So here's a few pages out of the updated interface reference. And GitHub contains a block of standard reference streams in case any new parsers are going to be developed down the road. And so just overall, DOS2 was designed to support instrument operations teams. But we kind of hope that by working with other groups and taking into account your needs and following internet standards, and releasing open source software, that DOS2 could be useful in a wider context as well. That's it.
Thank you, Chris. And I confirm that this is useful. So, okay, my turn. So this is a short presentation that I wanted to add. I don't have extra material, but that was following a discussion that we had on TAP and EPN TAP recently. So TAP is the Table Access Protocol. It's developed by the Astronomy VO, Virtual Observatory, and it's really dedicated to query on a relational database with an SQL-like language, which is called ADQL for Astronomy Data Language. And the result is in VO table, but it could also be in other language, in other formats. TAP is a very generic standard, and so it is reused outside astronomy. And in our world, heliophysics and planetary science. So TAP services are now implemented for many ESA missions and for Solar Orbiter, for instance, the latest example to date. EPN TAP is a flavor of TAP, so it's a real TAP service, but it includes a specification of the table names and the table column contents. So it has a metadata dictionary that has been developed for solar system sciences, which includes heliophysics in it. So EPN TAP is a way to share a table for each of your data products with query with metadata that can be used to query and search for data. And so the query parameters include the coverage, the provenance, the content, the access. And each service is registered in the IVOA registry so that it's discoverable automatically by clients. Once you have EPN TAP compliance on your service, then the same query by a user is sent to all services. And so the user doesn't have to know what is the endpoint of your service. And it can be accessed also to any TAP client because it is a TAP service. And currently, there are something like 55 services, EPN TAP services that are online, and a third of those are serving heliophysics data. Next, Jean, are you online and do you want to say a few words?
Yes. Hello, I'm Jean Aboudaram from Paris Observatory, and I am talking about BAS 2000, which is a database which contains ground-based solar observation visible on radio wavelengths. This is observations from France, Portugal, and Belgium. It contains also heliophysics feature catalog, which with filaments, active regions, sunspot prominences, coronal holes, type 3 radio burst, and some other features, and high resolution solar spectrum ranging from UV to infrared wavelengths. Thank you. BAS 2000 has the following characteristics also. It is a World Data Center for solar activity of the World Data System. It holds certification by a Core Trust seal. All data are under CC BY and CSA license. Most of the database, thanks to Baptiste, is accessible using the EPN TAP protocol. And we are currently working on allocating DOI on all data and also on the added value we provide in the database. Thank you.
Thank you, Jean. Next is Vincent.
Yes, you hear me?
Yes.
Okay, so same format as the previous presentation, still on Lambda, and the way we implemented API on it. So I don't repeat everything I said just before. The idea is that interoperability is one of the key features of Lambda. We implemented EPN TAP that Baptiste just presented a few minutes ago. We have also SAMP from IVOA, which is working on for data parameter distribution, and we have some REST and SOAP web services to distribute data and also to favor bridging between tools from CDPP, but also from elsewhere. So we are very happy to say that API is now running on AMDA for 650 dataset. What you have just below is a representation of AMDA, of Solar Orbiter public data from the MAG instrument plotted in AMDA on the left, and on the far left you have the AMDA tree, and then the plot for the magnetic field and the heliocentric distance from Solar Orbiter. And on the right, this is a plot in autoplot done for the same data using API. So our feedback is on the next slide, Baptiste, please. Okay, so with Baptiste and Alan Lowe, 2 years ago, we implemented a quick and dirty prototype. In 2 days, something like this. It was working for just a bunch of parameters. And now, thanks to Benjamin working with us, we have a full development, and the implementation plus integration took something like 5 days, including testing. Okay, we had the web services working very well as a starter, so it was not a full implementation of all the process, but to implement the Node.js server and the rest was about 5 days. So here I described what we did with the server. We had no major issue. We have some red lights that appear in the validation test, but it's problem linked to AMDA. It's not linked to API. But the plus we have is now a way to test all our parameters at once, and this is very practical with a validation test procedure embedded into API. Okay, now you can use it. Thank you.
Thank you, Vincent. So we switch to the SolarNet presentation by Benjamin. Benjamin, you're online?
Yes, I am. Hello, everybody.
Okay, thank you.
With the SolarNet project, we developed a virtual observatory that is very closely based on the American Virtual Observatory. And the idea was to be able for the people of the SolarNet project to share their data that they acquired with the SolarNet project, but also to share the data that we have at the Royal Observatory of Belgium. And so we had two big concepts with this. Is one, simplicity for the user and simplicity for the data provider. For the data provider, we ask very little requirements from them. Basically, the data observation and the wavelength, because you are mostly interested in solar images. And because most of those are in FITS file, we have scripts that help them to just parse the FITS files and extract all the metadata and put them in our metadata database. For the user, we wanted also to be very simple of use. So we have a web interface that is very intuitive to navigate. But also, if you want to use Python, we have a package that you can install. And for people who use IDL, it's a simple file that you download, you compile it in IDL, and then you can start searching and downloading data. We have many ways of searching the data. You can search across data sets. We have specific search within a data set, but also by solar events. So we have access to the HEC, heliophysics event knowledge base solar events, and then you can select solar events, and then it will tell you what data correspond to that solar event. And so the idea is to really help also people to find data that they would have not thought about. Can I have the next slide, please? And so the structure that we have is very simple. We have the database with the metadata. We do not store any data ourselves, just the metadata. We have a RESTful API that is protecting the database, we'll say. The data providers can push the metadata ourselves. We run the script and go fetch the metadata inside the FITS files. And then you have the web app, the IDL API, the Python API. And because it's a RESTful API, you could develop any kind of tool that use it and solve it. And that's it. Thank you.
Thank you. So we switch to Eric for MEDOC.
Hello, do you hear me?
Hello, Eric.
Yeah. So I'm presenting for MEDOC, which is a Data and Operations Center for Space Solar Physics. And it's from Université Paris-Saclay, CNES, the French Space Agency, and CNRS. So we have many data and tools at MEDOC. We have a space observation data archive. So we also redistribute this data. We have processed and evaluated added data and tools for analysis and interpretation, in particular visualization, like a HeliViewer server. And we're also doing operations, in particular for Soro Golf and Solar Orbiter Space. And for the data archive and redistribution, we are using the CNES CTools tool, which provides a web interface and a REST API. And also it includes also CAP and ConSearch. But our solar data are not for the discovery and data access. They are not to VO standards, so that's why we decided to publish at least the derived data that we produced locally with EPN TAP. So next slide. So for this, we're using DAX server now in version 2. And this is also the same as used by other services in our laboratory. Services that are not in MEDOC but are still in the same lab, so we use the same expertise. For example, for Mars Express Omega. So we have a dataset that is already published using custom grammar in DAX. So there are maps of temperature of emission measure in the solar corona. And so we have another dataset in development, which is a dataset about EUV synchronous synaptic maps. And for this, we realized that as it is a dataset that is evolving daily, we needed to do frequent re-ingestions of the database. And it's a database of about 10 years, so we don't want to do this every day. So that's why we're trying to use a direct use of the underlying database using another grammar from DAX, or DBT grammar. So then we will have this service available in Vespa, and so when all this will be working, this will be also the opportunity to ask a publication of the VSO.
Thank you, Eric. So I didn't receive the 2 slides from Imad Hassan, but I think he talked yesterday, so I think it's fine this way. And so then we have the 2 slides of Bobby from the SPDF activity.
Hi. So SPDF is the non-solar NASA heliophysics archive, and we've been busy pulling in the make it hard for me. Pulling in data from all the new missions.
I don't know why. What happened?
Solar probe, and I can keep talking. I know what it says.
Yeah. I don't know what's happening. Sorry. Go ahead. Yes, sorry.
and we're starting to do solar orbiter and ICON data, and we're getting the final data. The Van Allen probes and twins are reprocessing their data with their final calibrations. NASA headquarters has asked us to be more specific about what new missions, what the formats and other requirements are on the new missions. And so I've got a link there to our new requirements, and I think we'll keep adding to those. And then Aaron already mentioned this heliophysics digital resource library idea that we're pushing ahead for as we figure out what that means. And we're thinking of adding a web service for event lists that we had approached before and decided not to back then for other reasons, and then we'll go back to this. For CDWeb, the metadata and displays, we're going to start showing the space resource IDs and DOIs as those are all getting defined. And I wanted to bring up a little note that we've renamed some of our websites to make them consistent. people were unhappy that we had so many different names for the same sites. So we've removed this .sci from the middle of the name. So citaweb.gsfc.nasa.gov is the new name. And as you probably already figured out, if you use FTP, we've changed it so that it's encrypted FTPS, which doesn't work in the browser anymore. So you have to use command line tools or other clients. And we're adding NetCDF support to CDWeb, and we've added a new attribute variable purpose that's allowing us to sort the variables, the display of them, and ordering them. And it's the CDF, we're planning some new features, and we'll systematize the ISTP metadata guidelines a little more. Please see I have a more extensive presentation online that has a lot more detail here. And we've added we're going to add the end dates. We're now allowing end dates, and I will add that to the ISTP guidelines soon. And we're finding the Java-based tools. We had this 4D orbit viewer and the SKT editor that it's becoming harder and harder to support Java. And so we're going to look for alternatives for those. Next slide.
Yes.
Oh, that's okay. The other slide.
It's back. Yes.
Yeah. It's just our statistics. You can see that, we've got we're very popular service. We have a lot of people downloading files and getting plots and that sort of thing from us. And we're actually acknowledged in the journals quite a bit. 34% of the JGR Blue papers acknowledge our services and data. So that seems quite high considering they don't have to acknowledge us as we're kind of infrastructure. And that's it. Please see the longer presentation in the proceedings.
Bob, what is the y-axis?
It's 10 to the 5th. 10 to the 5th.
10 to the
5th number.
So the top is 600,000. Is that, am I doing that right?
Yeah, 600,000 what, requests or users or?
Yeah, actual requests. Yeah, we don't actually track users. And then the red line is actually 1/10 of that. So the what? Yeah, right. But the red line is actually 10 times that. So it's 6 million
6
requests.
million files requested.
Yeah, 6 million files, right.
Okay.
A month. So
that's a lot.
So there are sites that just continuously download our data. They're just always walking the directories.
So just to make sure, Imada-san, do you have 2 slides to show, or are you okay this way?
If I can show you, I'm very happy.
Because I don't think I received them, so that's why I couldn't include them. But if you can show 2 slides, then that's fine.
Okay, just 1 slide.
Okay, 1 slide.
Okay. Can you hear? Can you see my screen?
But we see the WebEx screen.
Okay. Wait a minute. Sorry. Okay, I understand.
Okay.
Yesterday, I already introduced the Hinode Science Center. So I want to concentrate on what is the SOLAR-C UVST mission. SOLAR-C UVST is a JAXA Epsilon M class mission, and the science goal is a fundamental step toward answering how the plasma universe is created and how the sun influences the Earth and other planets in our solar system. And our science objectives is understand how fundamental processes lead to the formation of the dynamic solar atmosphere and the solar wind. So that means solar wind acceleration and coronal heating. And the second science objectives is understand how the solar atmosphere becomes unstable, releasing the energy that drives solar flares and eruption. So the second science objects are flare or CME eruptions. So our strategy to tackle these objectives, our strategy is to quantify the processes of mass loading and energy transport conversion at work. So to do that, there are three key features. So first one is a wide temperature coverage. So we will cover 10 to 4 to 10 to 7. So 3 order temperature coverage. So observe the whole regime of the solar atmosphere as a single coupled system. So that's one important key features. And the second one is a high resolution. So spatial resolution is 0.4 arcsecond. This is one of the highest high spatial resolution in the corona. And the temporal resolution is roughly 1 second. So it's also a very high temporal resolution. And capture the dynamic evolution of elementary structures. So that's the second important point. And the third one is a spectroscopic observation. So determine the physical states of the target. For example, velocity, density, temperature, composition, or ionization. That's what we want to do with the solar CUVST. And solar CUVST observe the UV or EUV emission lines with the spectroscopy observation. So we can, so far, we believe we can achieve these science objectives. Okay, that's it. Thank you.
Thank you. So,
did Yoshi have a talk or?
No, Miyoshi told me that that was fine because he had the presentation on Monday, and so he proposed to.
I got yesterday. Yeah, thank you.
Yeah, okay. So, what do you want to? Maybe if there are questions now, if people are not too tired, we can have a few questions to people or start a discussion on how to relate databases and tools, or we leave that for Thursday, the group discussion. This is up to you. If people want to start up a discussion now, it's fine. If you want to postpone because people are tired or have other business, it's okay too, because we have passed the time. What do you think?
I do have a single question.
Yeah.
So I've never attended this meeting before, and so what's the status of VO tables being accepted as a data distribution format for heliophysics? They seem to satisfy many of the requirements that people would need for data delivery. They're certainly a flexible format, especially 1.4, so I was just wondering if that's been discussed by this group.
Not recently. We discussed that a long time ago at the HDMC meeting at some time, when we discussed the event list format. There was the heliophysics event list so we decided at that time on two formats. That was a CSV text-based simple format and a VO table format. So both were allowed. And so there is no recommendation by any other people in heliophysics saying that we should use VO table, but there are many tools available that are serving VO tables as an output, especially in Europe. So, and also now at IHDEA with the TAP services on Solar Orbiter, the output is a VO table. So we could discuss that to see if it's an acceptable format or not, and then if we want to use it and it's fit to our needs, we can also have feedback to the developers and the maintainers of the VO table on the astronomy world. They are really open for this kind of feedback.
I was very impressed with the specifications.
Yeah,
that's right.
Okay. In the space information model, in the access information, you can say what's the format of the data that you're accessing. One of the allowed formats is VO table.
Okay.
So technically it's supported in SPACE in terms of identifying that you might have a VO table format for the data, but you could also have other formats alongside that, because you can have multiple access information.
Okay.
So
but it's
not in the standard.
voluminous as
It's not in the standard list of data set allowed things in NASA's data policy.
Right.
Yeah, on the IHDEA website, it's not written. I think it would be nice to have this, but this is an assessment that we probably have to do in a working group.
Yeah, it's too voluminous for data. It's good for summary things like what EPN TAP returns. Here's the products that meet your specification, but it's not
Catalogs,
good for,
tables of metadata, high-level tables and catalogs that fits well into a VO table. Yeah,
but not for high-volume data.
It's possible, but it's probably not so well suited. Yeah.
True, and along a similar line, I mean, even in access information, you can say it's JSON format as well, which is probably more compact than VO table, but it's also an API-based stream. So
VO table is not a data format in the sense of a well-developed, fits an idea, and particularly CDF with the ISTP standards really gives you a lot of constraints on the metadata. There are no constraints on the VO table metadata. You need to develop those in order to make it a reasonable general format for data production.
Well, I don't totally agree. If you take CDF without ISTP, it's much less a format than VO table in this case. CDF plus ISTP is
that's good either, but
but
for instance,
VO table really there is a lot of specification in the VO table format on how you annotate your columns. So
well, but still, you want to have time be one thing and not anything you can define. For example.
Yep. Yeah, I agree. And this is why this is why for instance, on the EPN core model was developed so that the output table always have the same column name for a given quantity. So it's it's VO table plus a model that tells what are the names of the columns and the units that should be used. I agree.
So Aaron, I kind of have a question here in terms of if IHDEA recommends supporting VO table as a format, for that to get into NASA's data policy, NASA has to take some action, right? And
yes,
I think at NASA, they're pretty happy with the formats. Yeah.
So you mean that to have an IHDEA recommendation, it has to be approved by NASA?
No.
Okay.
I'm asking about, I guess, the process or maybe even the likelihood that NASA would then update their data policy to include that.
Well, it is used by NASA. The astrophysics division of NASA is using VO table somehow.
They're using VO table, but they're not using it for their data sets. They're using FITs.
Yeah.
Yeah, it's event lists.
That's the thing I'm saying. VO table is very useful for certain things, but not for big data sets.
I agree. We discussed with Chris at some point to use VO table as a more standard format than DAS2Stream for streaming data. And I think that's possible. That would fit into a VO table encapsulation, I think.
And I think a lot of people have a misperception about VO tables, that they're only this ASCII format that's very bulky. They're not. There's a binary format that's very flexible, and that's the one that I care about.
Yeah. Basically, you can make a VO table, for instance, that is just a wrapper on top of a FITS file.
Yeah, it's basically FITS plus is what you get with VO 1.4.
Yeah.
Okay.
So we could have a look to it, and I think it's worth trying to assess that. I agree with Chris. Okay. So I don't know if Jack is not online. Are you online, Jack? Nope. Jack Ireland had a question yesterday on the EPN TAP services that were, or the TAP services that were available. So in the presentation, we see that there is BAS 2000 and MEDOC that are serving TAP tables for that would fit very well, I think, into the search interface of the VSO. So if you can harvest those data set, that would be very nice. I think that would, if they have a type client, that would be straightforward to me. And there are others that I can list if he asked me, or maybe during the discussion.
Just hopefully quick, can we get to the AMDA space descriptions?
Mm-hmm.
Are they publicly accessible? And
yeah, there was a question about where is the repository. I saw that.
Yeah, the URL that was given is to the Explorer, but that's not really the Git.
I'm not sure it's public. Vincent, are you here? Or I don't know if Vincent is still here.
Talking about Kness, right?
Yeah.
Yeah.
Yeah. I went and explored in there as well. They seem to be following the same sort of resource ID patterns that we use.
Yeah.
So I'm guessing it's in a Git repository, but I don't know.
No. There is. I checked. It's not. I don't think it has been pushed into the HPDE GitHub repository. So I suspect it's an internal GitLab repository that they are using at the moment.
Yeah. I asked because he referenced it as cnes.git, which indicates it's a Git managed collection.
But it's not on GitHub yet.
But it's an internal. Yeah. Thing. It would be nice, if it were tied to the GitHub Kness repository, then all the tools will work on it, right?
Yeah, feedback to the AMDA team.
Well, it's not only them; it's the whole world that needs to expose their metadata. Open data, open metadata.
Mm-hmm. Yeah, that's too bad that they are not here anymore, because I had so I discussed with them in the last days. For instance, for their own purpose, I think they have copied part of the space registry with the persons inside their own registry, which is something that would probably work better if they pulled regularly from the HPDE registries instead of having a local copy. But yes, Daniel, you are here. Yeah.
Hello, I listened a lot because as you know, I am not an expert, so I prefer listening. It's completely true what you are saying, and we are the local repository, and this is for the moment we have absolutely nothing because it is under migration. Okay.
Yep.
But what is planned indeed is to have a local repository, and then to perhaps in parallel, and to have to push the metadata on the HPDE place location. With of course is how to manage maintain both in parallel. So honestly, at the moment, I don't know what is what we should do on the hierarchical organization. Okay, but perhaps we could have discussions apart.
Yeah, we will have an offline discussion on this. Yes. Yeah. Okay.
I guess the word is we would encourage that very much so to have the metadata put into the GitHub. Yeah.
Okay.
Just to be clear, it's okay if it's in their GitHub. We just need to be able to keep in sync with any changes and have our own copy of it.
Oh, that's a very good point. As long as they have a repository that's publicly accessible,
A question
works
for
fine.
Todd. A question for Todd. I thought, Todd, you were supposed to validate all that is supposed to be available on the HPD repositories. Is that still the case?
The question is who validates? Yes. Who validates what is pushed to HPD repositories?
Yeah.
We're only pulling. Yeah, we're only pulling from what you have. So it's the individual people who have repositories that validate their own resources. All we do is get a copy and refresh on a daily basis. That's the way I look at it anyway. I think, do you agree?
For the most part, yeah, but we do have tools to help with the validation process for those people.
I assume they're using them already.
I would think so.
That's why it would be good to have them on the continuous integration phase, so that you make sure that what you want to ingest into your system is valid.
Yeah, we also need to make sure that all the users know what tools are available and they can access it. Communication.
Yeah. But I must admit, when I proposed things to the records to the SMWG in the last months, there was a lot of feedback from the HPD team to update what I've written, what I was proposing. It was not false regarding the space standard. So, but it was how do I say that? It was not the usual way of doing it. and so as I didn't do it the usual way, people wanted me to change it, and I changed it. But so it means that there's still the unwritten rules that makes it easier to merge with the other resources that should be either written or validated, or then there should be an overall last validation to say, okay, this fits to what we want to do.
I would probably be.
That's why we need to see these things. If we can just look at what AMDA has and see, does it converge or not, and in what ways do we have to change our conventions on both sides?
And of course, you're mainly talking about me interacting with you on the review.
Not only you.
Not only me, but Rin was on it, and but the.
It's good to have feedback anyway. But if naming authorities are on their own, this feedback is not there anymore.
I agree. But as we did this, we actually found quite a few things that ended up. Some things weren't even registered because they weren't necessary. We found things at many different levels. And even though it was painful, I think it was a good exercise. And
I think so too.
at some level, this needs to continue.
Yeah.
Well, I hope people are keeping in mind what working groups they would like to form.
Yeah, there can be a metadata curation group. Okay, any other discussion for today?
Well, we're probably good for today.
Yeah, I think, well, it's probably back on what we discussed earlier or mentioned earlier. If we want to increase the usage of either space on one side or HAPI or whatever protocols that database are implementing, and if we advertise that in space with the access information, we have to formalize the way it is written in space, and we have to explain for tools how they can automatically discover, and if they have a happy client or a tap client, they can query that service. So there must be enough information in the space record so that people can build automatically interfaces to those databases. And I think if space is the place where tools builder can find this information, then space is very useful.
I'm going to ask one question that maybe the minority is not asking. That is, we've always talked about space, and space seems to be the only model that's being talked about for metadata. Is there another one out there that people tend to use that we don't know about? Are there people here just to learn about space, to see how they compare with what they're using? Because IHDEA keeps talking about, we want to promote using standards, but yet space is the only model that we have talked about for metadata. Are people using another set of model that we need to be aware of?
Wasn't there an IVOA metadata standard?
There are plenty of other ones.
Yeah.
Now, ones that are fit for heliophysics. I don't know.
There is Benjamin Montpig talking here. There is the SolarNet project had a document that tried to make a standard for metadata in FITS.
Yes, for FITS format. Right, you are right. Yep.
A metadata that's specifically for a given format, data format. Mm-hmm. But the metadata should not be dependent on the data format itself, should it?
It's not totally dependent on it, but it takes into account the limitation of the FITS format, which is, for example, that a keyword should not have more than 8 characters. So that's why we say it's FITS, but it's not, you can use it outside of FITS.
But doesn't space do that too?
Yeah,
well, you can do a mapping.
CDF is another example where there's metadata, there's standard metadata for CDF files, but it's not the same as space, and that's why Lee is doing what he's doing.
I understand. So there are formats out there that are not
the same thing.
Right. And it used to be.
It's not a metadata, general metadata standard. It's just what you do with FITS files.
Right.
Yeah.
I mean, it's the same for cluster exchange format. It has its own metadata dictionary that has some differences with space. So we can decide to use space as a standard, but it's not used all over the world for every single format as the standard at the moment.
What could be done if we want to increase interoperability in this case is to, from those format-related standards, or at least formats standard, the metadata that has been built to work with a given format, is to do the mapping between those formats and maybe with space, so that it's easy. So it makes it easy first to extract a space record metadata from the header of those files, because you have the mapping. And then it will help us also to see what we need and what is missing in space.
I mean, I did some mapping. I developed a tool to convert basically CEF files to CEF ISTP, and the mapping. Some of the keywords, let's say, are straightforward to convert. Some others are not at all straightforward. Sometimes the same property is used for different things, or it's named the same. So it's not impossible, because we did it for cluster, but it's not easy.
Well, it is impossible in some cases, and that's the evolution that we've been going through. We've tried to take the various sources of metadata, including the CEF cluster exchange format was one of the things that went into the mix in generating space.
Yeah, it's not always possible because the modeling is different. The structure of the model inside is different. One thing that
Right.
is used by SDO for the, I think it's the heliophysics knowledge base. It's a VO event, and I know that people in Brussels are also studying this. So VO event is a format, but there is metadata that is that are defined in the standard. So that's something that exists also. It's dedicated to events, but it's working also for solar events.
Was there a complete and simple mapping between SPACE and the PDS? I know Todd King's here, so he might be able to answer that.
Well, there is a mapping I know we did. Yeah, I'm not sure. I know internally at PPI, it's a mapping, and that mapping is what NSUK is using to support the Happy server, I think, and other things.
That's another metadata model, so I just wanted to bring it up.
Right. There is a mapping. I did one a few years back.
Yeah, I
so
did
that
one.
we could do translations.
But actually, all those.
It's not directly one to one, but they both share very common concepts about the data,
but the thing is that
parameters and things like that.
Yeah, all those models that we've cited have been developed for a purpose. One have been developed to use in FITS format, other in CDF, in cluster, for events. For the PDS information model, this is the goal is to be able to have the metadata for the archive at the PDS. And so each purpose, so there are common metadata, but not all the metadata can be mapped because, the purpose was different in the first place.
I think a useful term for this I got from Doug Lindholm at LASP, where he has both discovery metadata and use metadata.
Yeah, doubling core is indeed used by. Yeah, it's there without because it's the core metadata that's the citation core metadata.
But it's the A in SPACE is archived, by the way, so we have that in mind. And also, going way back to when you kind of opened this up, Baptiste, it's clear that Happy is able to get to lots of data sets using SPACE metadata. There were 2,500 from SPDF alone. So I think it's...
Actually, Happy has its own model for the data, which is simplified from what SPACE does.
Happy is focused on the use metadata, like Lincoln was, Jeremy was saying, with just the access mechanism support. So yeah, it's a subset of a lot of these other ones, just focused on what does it take to get to things. So it's not really meant as its own separate metadata thing. It's just meant as a lowest common denominator that anybody could produce based on whatever metadata they already have.
I guess my point is you're feeding off the SPACE metadata. It's sufficient to power your system.
They don't use it.
No, it's not driven by SPACE.
But
it depends on. Go ahead, Todd.
I was just going to say Lee's statement is accurate in that SPACE metadata is sufficient to power a Happy data server because it's got more information. It's got the required data use information and more, so it is sufficient, but Happy doesn't use it in that way, right?
That's not really the right way to say it. It's not that Happy uses or doesn't use SPACE. It's because Happy servers, they're independent. And so if you are already SPACE driven, then yes, you're going to use SPACE to drive your Happy server. If you have something else, then you're not going to use SPACE first and then do Happy. You're just going to map whatever you have to Happy. So if for CEDAWeb, yes, they already have SPACE, but I don't know what NAND is doing. Is he using the SPACE to drive his Happy server? He might not. He might be going directly into whatever they use.
CDF.
Yeah,
Probably
he's
just
using
CDF metadata.
He's using the CDFs because the space may or may not actually represent exactly the variable names from the CDFs. So it's,
It should.
Well, but that's way different than it does.
Well, of course.
Yeah. So that's why the happy stuff is meant to describe the content that you're actually going to get in the stream. And so you can drive it with space if your space is fully logically linked to your data.
And I think that's maybe a topic for this group, and that is currently there is no implementation of a happy server that works directly off the space descriptions.
That's because the space description there's so many things that are not required or that it's not guaranteed that you would have to have space plus these extra constraints to get enough in the space.
Well, yeah, but in a lot of the metadata we do, we already implement those extra things. Like we want to have parameters included always, and we are ensuring that even though the base model says they're optional.
Right.
Okay. But I guess for this group, see, if we were to say we would encourage or endorse the development of a space metadata driven backend metadata for a happy server, then we kind of have an ecosystem there that has some, symbiotic relationship between the data server and the metadata that we use to describe our resources.
John, I have a question. Does happy call contains a parameter request?
Yeah.
Say that again.
It gives you a list.
It's a requirement, right? So all the CEDAWeb data that we have that without parameter descriptions right now cannot satisfy a happy call.
Correct.
Right.
With the space description.
That's right. That's right.
But but when you go down to the data level, like CDF, you inspect the CDF, you're going to get the parameter list.
Of course, I think that's the difference. So
the reason why
because they don't have it's the parameter call requirement.
The reason why it's quick to stand up a happy server now is because people already have data servers. They're already serving data sets and parameters. And so all you need to do is to sort of happify that. You need to wrap it with a happy mechanism. And there's a mechanism for doing that just turns the interface that you have, which is, we try to make it lowest common denominator. It's very close to what you already have. So happy is connected to the data, and whether or not the metadata it matches that's a separate question. And that's why we didn't link them more explicitly, because there's too many cases where it would take a lot more effort to synchronize everything.
Right. But if we undertook a happy wrapper around space metadata, we would have another option available.
But just because you have space metadata, that doesn't mean you're serving the data.
Correct.
Indeed.
No, I know, because it's actually they're maintained separately, right? Because the space metadata has the access URLs, which is really the path to the data, and right, it's not the server doesn't necessarily
Well, the access.
I understand your point, and that a happy server that's just looking at the space metadata isn't necessarily adjacent to the data itself.
Well, so if you look at things like Madrigal or SuperMag or whatever, they don't have anything space, and so we're not going to ask them to go space first and then happy. We're just going to say tweak your data service, and then make it compliant with this spec, which is close to what you're already using.
Yeah, it's more about what information is contained in your metadata description.
Right, but I think the overall ecosystem that we're trying to put in place here, I think we need a good architectural description of that, in the sense that, okay, you might have happy server next to the data, so that it can become an access URL that complements the metadata that you would use to fully describe the resource, in space. So I think we need a good architectural discussion.
The architecture has to be realistic. If we were starting from scratch,
of course,
that's what we would do. But we're starting from everybody already has their own servers and services, and so we're just trying to tweak them. We're not asking them to start over and start from a metadata-based approach. Yeah. So
yeah, that's kind of what I'm saying is, we're having this discussion about how much can the phase metadata drive the happy, and based on, as you described it, that's not really maybe the optimal architecture, that you put happy in front of the data and the space description tells you how to get to there.
That's the stop symbol from Baptiste.
I have a question. Is there any, do we have an idea of the number of tools or interfaces serving data that are based on space inside?
There was
data portal.
Yeah.
So I know AMDA has a specific flavor of space because they are missing things, so it's space plus something. So there is, of course, the geophysics data portal. And is there any other tools that are built this way? Maybe HugoNet has space inside. So it's not so many tools that would have that could use this space happy interface.
Right. The space helps you find it, but that's the main point of space, is to capture what's out there so that we can catalog it and find it. And then, but it's not it's just the description of it. The services are already there. People have built them from whatever they were optimized for in the first place, different purposes. So
yeah, I think that's part of the distinction we need to articulate a little better and when we talk about things. Like the data portals are a good example. They use the space metadata to aid in the discovery of what data is available. But then they have a get data button in the case of like the HP data portal. And that get data button is exercising one or more of those access URL type things, which one could be to a happy server, or it could be to a file, FTP server, or it could be to a different type of data access method. And so there's a kind of a sequence, right?
But we need to keep them separate so that the data access mechanisms can evolve and the metadata doesn't have to be totally linked to it. And we have, I saw in Xing's thing about space inside or happy inside. It's like, I don't know that happy inside makes sense, because it's really happy's the interface to the outside.
The outside, yes.
Happy outside. Who cares what you have inside? But this is the interface that's on top of it, right? So, and it's kind of the same almost, with space, where it's like, if I want to search your stuff, I'm familiar with space terms. I want to conduct my search based on space, and that seemed very useful for what Arnaud put forth with the dataset descriptions, where he harvested the space to say, hey, these are the keywords, and this is how people view it. So it's more how these things connect with each other, and less what's inside. So if we have mechanisms for people to, what you're talking about is if we have mechanisms that allow people to add new things into this ecosystem in an easier way, then we can get there eventually. But we're mostly starting from people having their own systems, and they have to adapt what they have into the current or emerging standards.
Okay, so I think we have to probably stop because it's already late. I see that there is still our Australian colleague connected. So yeah, probably it's unless there is really a strong will to go on, I think we should adjourn for today. So we'll meet tomorrow. I just urge, and I will send an email back, the people who had short presentation to send me the 2 slides so that we can. So actually, it worked well. It's really on the long talk, the longer talks that we lost time. Well, lost. I think it was very fruitful discussion. I'm really happy to the discussion that are occurring here. So. I think that's it for today. So tomorrow we will focus more on software and IDL, Python, etc. Okay. Thank you for being here, and see you tomorrow.
See you, everybody.
Thank you.
Bye.
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 Bye.